training program on domain-driven design, and I will share that deck with you all later on. But you see this, if you go to this Wikipedia, you will get sufficient amount of things to at least get some idea about what domain-driven design is all about. So when we have a large application to be designed and developed, we take the approach of domain-driven design. And in case of domain-driven design, there is a concept of subdomains. I repeat, there is a concept of subdomains, and each subdomain will have its own data model. I'm so sorry, I will take back my words. I won't say data model, I will say domain model. Each and every bounded context, each and every subdomain is actually a bounded context. Don't worry about these jargons, but it has got its own domain model. What is domain model? Domain model is actually modeling the business domain and identifying the classes that are the part of that particular business domain. Okay, that's what domain modeling is. Okay, identifying the entity classes, identifying the classes that exist in business. Please, 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 especially Ram, you will not think in terms of databases at all. I understand you come from Oracle background and a .NET background, that's fine. But then from Oracle background, especially what you have on your mind at the start of the day and the end of the day is database, 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 and database. Stop thinking in terms of database. Now you have to play down the role of the database, play down the role of the database. Not that it is not important, not that it is not critical, but you have to play it down. Right? So you stop thinking in terms of databases. You have to start thinking in terms of classes, 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 and classes, especially with respect to domain classes. These are the classes that exist in business. Now see, very simple thing. I will give you two requirements. I'm putting two requirements in front of you. Tell me which one of the two requirements is non-functional and which is functional. When I say non-functional, it is actually the short form of business non-function. And when I say functional, it relates to business function. Okay, I repeat, non-functional is something which is software only, quote unquote software only. And when I say functional, actually it is the short form of business function. So business function related requirement. I repeat, when I say functional requirements, it is about business function related requirement. Okay, very interesting and important stuff here. So I'm giving you two requirements. Tell me which one of the two is non-functional and which one is the functional requirement. I repeat once again, when I say functional requirements, I am talking about business function. And when I say non-functional, I'm talking about software only. It has got nothing to do with business domain. It has got nothing to do with business domain. It makes sense only and only when the software is in place. I will give you two requirements. You've got to classify which one of the two is business function and which one of the two is not a business function. The due date of an invoice is 30 days from the date of invoice. I repeat, the due date of the invoice must be 30 days from the date of the invoice. This is one requirement. And the other requirement is the software must respond in less than 3 seconds for any given request. You have to tell me in the chat window, you're going to tell me, don't unmute yourself, that's fine. In the chat window, you're going to tell me which one of the two is functional, which one of the two is non-functional. Can I get some answers here?
Yeah, obviously.
Right.
The first one is the business related thing, whereas business is asking for a specific function where the invoice date is or your credit terms are 30 days, wherein the second part is purely system.
Superb. Absolutely, that's how it is. Absolutely, that's how it is. Because if there is no software in place, this particular requirement does not make sense that the system must respond in less than 3 seconds for any given request. It does not make sense at all, right? If there is no software. But the due date of the invoice must be 30 days from the invoice date is a business function. Whether you have a software or you do not have software in place, this requirement holds true in business. Everything is done manually, then also this requirement holds true, hence we call it a functional requirement. Correct? Now, similarly here also, there are classes. For example, the classes that I have over here, see my training application, training risk controller. This is a class which is not the part of domain. This is not the part of business domain. My DAOImpl class or repository, this is not the part of domain at all. If I go and tell, if I go to the business and tell them, see, training REST controller, they won't be able to relate to it. I go and tell them, training DAOImpls, they won't be able to relate to it. They say, what the hell you are talking about? It's your software, you manage, whatever components you want to create. If I say service IMPL, say, what is that service IMPL? We don't care. But when I go back and tell them training, they understand. It's their business. When I go and tell them it's vessel, they understand. कुछ पैसे चाहिए आपको? अभी पैसे? हाँ, ठीक है. So when you say training, when you say chapter, when you say topic, someone who is in education domain understands what this analyst is talking about. If it's a logistics domain, and if I go and start talking to the business, vessel schedule, I tell them about shipment booking, I tell them about shipment instruction, they understand, they relate to it. That's what their business. So these classes are domain classes. Hammer it down in your mind. Very simple. These classes are what classes? They are domain classes. But if I go to the business and tell about vessel schedule service IMPL, they'll say, what? I'll tell them vessel repository. They'll say, what? Correct. So you understand now what is a domain class and what is a not, what are other classes. So only those classes that are the part of business, the real world business, they are actually the domain classes. And when I say domain modeling, now my dear friends, it is needless to say that I will be modeling the classes that are domain specific. And that's the first thing that you start with, because you are developing. See, we are not developing. Tell me one thing, friend. This is the IDE. This is my Spring Tool Suite IDE. This is also software or not? This is also a software, right? Someone has developed this software, but is this a business software? No, this is a development tool. So here the vocabulary is very different. We people do not develop IDEs like this. We don't build software. We don't build operating systems. We don't build development tools like these. We build business applications. I repeat, we build business applications, and we build business applications and business products. We have to, first thing is that understand the business. And when we start talking to the business stakeholders, what they start talking to us about? Do you think they talk about API? Do you think that's our job? Do you think they talk about repository and stuff? They start talking about business entities. The moment they open their mouth, they start saying that, okay, we have got the concept of vessels, and we have got something called vessels, and we have got our own vessels. We also have third-party vessels, and we take booking for our vessels. There are people who are NBOCC companies. They book vessels with us. These are all business terms, right? Business entity. So the first thing is that you need to understand the business. And if you have to understand the business, you have to model the business. Modeling the business here, with actually business modeling is a separate subject matter altogether. But what I'm focusing on is modeling the domain entities, the domain concepts, the model classes that are there in business. And these business entities are actually the model classes that we create in our model package. You might have seen that. Okay, so very important now. I will never have a class in my application called Vessel Master. Vessel Master may be the name of the table in the database. I may have something underscore GT underscore master or whatever. I may create the name of the table based on the principles of Oracle or MySQL or whatever RDBMS I'm using. I will follow the normalization principles there. I will follow the database related things when I talk about database. Database comes later, because I may decide, I'm just putting a point across and proceeding further. I will take up Cassandra as a subject matter later on all by itself. I may decide not to use Oracle and use Cassandra. The $1 million point here, Cassandra, the very essence of data modeling in Cassandra is denormalization. If I have Oracle as the database, it will be about normalization. Right now, here it is all about denormalization in Cassandra. We will discuss in detail later, but I will follow the principles of the database design later. First, I need to understand the business. I will not think in terms of database. I will think in terms of classes. Which classes? Controllers, repositories, service IMPls? No. First and foremost, I will think in terms of domain classes. I will try and understand the domain entities. When I say domain entity or a domain class, it's one and the same thing. I repeat, domain entity or a domain class, it is exactly one and the same thing. So the point is, we are supposed to do domain modeling, right? And what is a domain model? What a domain model looks like, I will very quickly give you, very quickly, I will give you, I'll pick up stickies over here. And I hope you can see my screen. I hope you all can all see my screen, right? It's I
Yeah,
have shared
visible.
this.
Yes,
Okay,
yes.
okay, okay, good, thanks. Now see this, friends, please see this. I will very quickly write requirements in front of you. Okay, there is a university. Yeah, there is a university, and that university, has got every 6 months they've got semesters. Okay, and each semester they roll out some courses. All right, and in those courses, and they have got students in their university. They must enroll, okay, for the courses that they would want to attend in that given semester. Okay, they would like to attend. They've got to come, and they've got to so university has come to you saying that please develop a software for us, and this is what the requirement is. We have got a university, we are a university, we have got six months of semesters, and for each semester we roll out courses. Right, we roll out courses, we have course offerings, rather they say courses, and we have course offerings. So there can be like for example, there can be a course called Java is a course. It has got ID, it has got name, we give a name to a particular course, like a Java course, and we say this is the duration is, no, we won't say duration is in course, but there are a lot of other details. But then we have a course offering. That means we've got a 6 months of course offering on Java, we have 2 months of course offering on Java, we've got advanced Java, we've got basic Java, we've got intermediate Java. There can be various different course offerings. The venue can be different. So course offerings are there, and the students who are there in the university, they are the ones who will enroll for the course offerings. They will enroll for the which particular course offering they would want to attend. That's how it is. And we want you to develop an application wherein the students will come and they will enroll for the courses. And the moment they say that, okay, tap, these are my 4 primary courses. Okay, there's a concept of primary courses. There's a concept of secondary courses. What does that mean? They say, this is my 4 primary choices. I would like to attend these courses. But if at all you are unable to give me seat in any one of these, then these are my secondary options. So the student has got an option to have 2 secondary, two other subjects, saying that, okay, 2 of the other course offering, then if I don't get any one of them, then please try and accommodate me over here. This is how it is. Correct. That's what the requirement is. Now we understand this and we start creating a domain model. So when I say domain model here, I will very quickly bring this up once again. Okay. All right. And then, what I'm going to do is I will have classes created over here. So when I say classes created here, you see you have got option of UML. Can you see this UML here in draw.io? So I will just pick up and I will create a class over here. What will be the name of the class? As of now, we will come to the fields later if required. I am talking about domain modeling. Please try and understand this. I will create a class called student. And I'm very sure, see, I don't want to run through the exercise wherein I give you some time to identify the classes and stuff. We are doing it together. So student is a class that I have identified. Makes sense? Then I have another class identified called course. Right? There is a course. You know what is a course here? Something as simple as, okay, I've got a course called course ID. Okay, there is an identification of the course, and there is something called, this type is actually what is the data type. I can put here integer. Okay, and then here I have something like name of the course, and then this will be of type string. Okay, and then here you are, maybe what I have is I will have, okay, leave it. I'm unable to actually think of something else, so that's fine. Then I have something called course offering. Right, this is different. We are discussing $1 million thing, friends. Please do not lose focus at all, and you will build what you will, by what you will be learning now. Course offering is what we have, and this course offering over here will have course offering ID. Right, I am not thinking in terms of, please, you may think that these are offerings, these are the tables in the database. No, these are classes in my system. These are domain entities. Whether I have a system in place or not, whether I have a software or not, they do have course offering. They do have an ID over their course offerings. This will be course offering ID. Okay, they do have a code ID for each and every course offering, like say C0112 in universities. You will see that. Now there will be a title over here, like for example, comprehensive. So what is the example over here? Java, for example, is the course. For example, is a course, and here you say title is 5 days of comprehensive hands-on training program on Java. That's the title. Okay, and then Here you will have, start date. Here you will have something like, more, I will keep on start date, end date, venue, all of those things will be there, right? And then I also know very well that when student in this particular domain, there is something called a student schedule. When the student registers and when he says that, okay, I'm doing the registration for these 4 courses in this semester, these are the 4 courses I want to attend. So what is created for that student? What is created is actually a schedule, a student schedule. Student schedule. Okay, I'll call it a schedule or whatever, right? Schedule ID. Okay, and then the date of creation. When did he actually create this schedule? Okay, and then the semester for which he is creating the schedule. Okay, semester. Okay, and so on. These are the things. So I've got this, you see this, I have course offering, I've got schedule, I've got student, all of these are the domain classes I have identified. Now we are coming to $1 million point here, friends. $1 million point. Don't you think these domain entities are related? There is a relationship between these domain entities, don't you think? I will name this as, isn't it, domain modeling? Okay, there are relationships over here. Definitely there are relationships. For example, student is definitely related to course offering because he's going to select the course offering and we want to somehow make this thing persistent in the system. Again, I repeat, when I say persistent, I may put it into a damn file, a text file. I may not put it in Oracle. It's my choice. I'm the architect. I will decide what is best for this application. So don't think in terms of tables in the database. Think in terms of business. Think in terms of business. So first of all, to start with, forget about even student for a moment. Course offering and course, aren't they related? Course offering will always be for a particular course. So I'll select this, and then I select this, and then you see this, I will have a relationship here like this. I will have a relationship. Okay. And here when I have a relationship, I will actually have a relationship. Sorry, just a minute. There is one thing that I want to do over here, which is this. Okay. Okay, sorry. Okay, this is what I wanted to actually do is that remove the arrow from both the end. Okay, and I just wanted to keep the, okay, no problem. Don't worry about the arrow. Just imagine that there is no arrow at all. Okay, so in order to do that, what I'll do is, because so that there is no confusion at all and the discussion becomes really concrete, let me do this here. I will have a okay, an association of parent-child relationship. This is just perfect. Okay, and don't worry about this, the child over here. We are not discussing that part. Okay, I'll remove that from here. Okay, so there is a relationship here for sure. There is a relationship. And okay, there is a student schedule created. Okay, there is also a professor. How can I miss that? There is a professor, and the requirement is that the professor is the one who will be actually giving grades and stuff and all. So let me create a professor here, and it is the professor definitely who will be teaching a particular course offering. So I'll say professor ID. Then I will have the name of the processor. Then he will have some qualification also, right? All of these are the fields here. And there is definitely a relationship here now. What is that relationship, my dear friends? That relationship is, I'll just bring this here, and again I will bring this here like this. Okay, there is a relationship here. I will remove this, and I will remove this child also over here. My dear friends, understand there is a relationship between the professor and course offering also. There is definitely a relationship. Correct? Because a professor is related to the course offering. Which professor is teaching which course offering? You need to have that information in the system. There is a relationship here. Now I will have student and the student schedule as well. So student actually creates, he selects tap. These are the 4 primary course offerings that I want to attend in the semester. He clicks on submit, okay, before that he says these are my 2 secondary options, alternative options rather. He clicks on submit, and a student schedule is created in the system. So there is definitely a relationship here. There is definitely a relationship here, my dear friends. Okay, and that relationship is like this. Correct? There is a relationship. Again, I don't want that. I don't want this. Okay, there is a relationship here, my dear friends. Got it? And student, when student says I have a student schedule to create, he does select course offering. That means there is definitely a student schedule that he created, saying that these are the course offerings that I want to attend. That means student schedule definitely is related to course offering as well. See, there is a relationship here. Okay, there is a relationship. So I will just create something like this and I remove this here. There is a relationship, correct? This is a relationship here like this, correct? See this? So there are relationships between domain entities, right? I mean, this will result into such a beautiful thing. You will just realize, hey, come on, man. Okay. Ganda ho gaya. Okay, this looks good. Okay, so there is a relationship here. So this is how I have created relationships. Things are going to get very interesting now, friends. Things are going to get extremely interesting. Am I thinking in terms of tables in the database? No. So the name of my class will never be course master. I may have a table in the database called course master. I will never ever have a class called course master. Right? I will have a class called course. I must be able to relate it to the real world business entity. I repeat, my classes, my domain entities, this is called domain modeling. Hello friends, this is called domain modeling, which is the part of your domain driven design when you design microservices. I repeat, this is the part of your domain driven design when you design your microservices. You do the domain modeling, you identify the domain classes. These are the domain entities. You may also call them as domain entities. These are the real world entities in business, right? This is how you do it. Now, $1 million things, all the more multi-million dollar things are coming ahead. Okay. The team will think at least we get something or not. We have $1 million points we are getting. So that's fine. Okay. The other team members once, the other earlier team used to ask Shagir, when is that $1 million going to come? Okay, no worries. It will come one day, inshallah. Coming back over here. Whenever there is a relationship like this, there is an association relationship like this. I repeat, these are all association relationships. What are the different types of relationships that are there between domain entities? What are the different type of relationships that you have got? Actually, all in all, between classes, these are the different types of relationships. Okay, see here. The relationships, one. Okay, one is association. Second, composition. Okay, third, or I will call it aggregation. Okay, third, there is dependency kind of a relationship. Okay, and then fourth, there is composition. Okay, right? There is composition. That's how it is. So you have association, you have aggregation. I will like to put aggregation and composition together. Okay, so I'll say 3, and this will be kind of 4, and association, and then after that I would like to put second as dependency. Okay, these are the kind of relationships that we have. I'm just deviating. I'm coming out of this for a moment, and I want to talk about these relationships with you. Okay, now understand these relationships from technical point of view. I will go back to my Spring Tool suite once again, and then what I'm going to do is I will create just a dummy class. I'll say class. Okay, I'll say class A, and then again I'm going to create a class, and I'll say class B. Right? There are 2 classes I have created, class A and class B. Now, when A wants to invoke a service on B, I repeat, when A wants to invoke a service on B, let me do one thing. Let me create class right here in the same .java file. See, I'll tell you, in the same .java file, you can create n number of classes, n number of interfaces. But the point here is that only the class, the name of which is as same as the name of the file, that can be public, rest will all be non-public. That means they will be protected. In that case, they will be accessible only and only from within the package, not from out of the package. Coming back over here, I'll say I have class B. Okay, these are the 2 things that I have, class A and class B. Okay, now class A wants to invoke a service on class B. So A is the supplier, A is the client, B is the supplier. I repeat, if A wants to invoke a service on class B, then A is the client and B is the supplier of the service, because A is invoking the service. So A is the client, it is invoking, it is asking for some service, and B is the supplier of the service. So here I'll say public void, I'll say demo. From here, I want to invoke a service on class B. Got it? Now, there are 4 ways in which the B can be made, object of B can be made accessible to class A. I need an object of B, right, to invoke the service. And suppose that public, I'll say public void, okay, some function here. And I want to invoke that some function from here on an object of class B. I have to create an object. So there are 4 ways only. I repeat, there are only 4 ways. The first way is that I may declare class B is equal to new class B over here. This becomes the, okay. Hey, क्या problem है इसको? I'm so sorry. Class B, okay. So I've got class B is equal to new class B. Correct, this is the way, and I can very well say B dot now, I can very well say what is the name of that function, some function, and I can invoke the function. If this is the decision that you have taken, if you have decided to create a field variable, this is called a field variable. I repeat, this is called field variable. So if you decide to create a field variable of the supplier in the client, the visibility is known as field visibility. I repeat, the visibility is known as what visibility? Field visibility. Okay, and then you can invoke the service. Okay, I'll comment this for now, and I may decide no. I'll say class B. We are not discussing which one of these 4 options are the correct or the right options. That's beyond the scope of our discussion. We are only discussing what are the 4 different ways in which the supplier can be made available to the client. So I'll say class B is equal to new class B over here. When I do this, I will see the visibility of supplier to the client is local visibility. I'll say local. Why local? Because this particular object B has been declared locally within this function, local visibility. So again, see, I can very well invoke the function. The third option, I may decide to pass the instance of class B as a parameter here, correct, and then get it invoked here. In such a case, if this is the decision that you have taken, if this is your design decision, see, these kind of design decisions are known as detail level design, right? Detail level design, low level design. Low means what? Low level? No, not low. Detail level. Okay, low level is detail level. Okay, so here this is called, I'm sorry about that noise, parameter visibility. Okay, this is called what? Parameter visibility. If this is what the decision. So 3 ho gaya, 3 types. One is field visibility, second is local visibility, and the third is parameter visibility, right? These are the 3 types. Now, the last and the 4th type is that you will decide to have this class B object created as a global object. When you say an object is declared as a global object, in that case, it can be accessible from anywhere in the entire application. How will I declare this as a global object? Simple example I will give you. I'll say class. Okay, I'll give the name of the class as I'll say okay, I'll say trainer application. Okay, I'll say trainer application. Suppose I create a class like this kind of called trainer application, and in this trainer application class, you know, I declare something like this. I'll say public static. Okay, see this, public static class B. Okay, the class B will be visible from here, no problem. Class B, okay, sorry, class B is equal to new class B. Okay, this is what I have done, correct? Okay, I am unable to access this from there because it is in this package. Okay, take it. Let me bring this here. Okay, now see no error. So public static class B is equal to new class B. Now the moment you say public, it is accessible from everywhere. The moment you say static, you just need to say trainer application dot you know, B, right? I'll write global instance of class B. right? This is what I have written. See the name of the variable here. Since it is static, it can be accessed from the name of the class directly. I don't need to create an object of training application in order to get it. And this is public. So I go back over here and I may do something like this, you know, I say training application. Okay. Why is this not visible? Trainer, sorry. Okay. Trainer application dot, you can see this global instance dot, I'll say some function. You got this? Like this. If I do something like this, I will say the visibility is global visibility. I'll say global visibility. Okay. See, these are the different types of visibilities, right? You got this? So what are the different types of visibilities? From the client to the supplier, how can supplier be made visible to the client? Either through field visibility or through local visibility or through parameter visibility or through global visibility. These are the four ways. There is no fifth way at all. In any object-oriented programming language, there is no fifth way at all. These are the only ways, right? Field, local, parameter, and global. That's how it is. Can you give me an example of any other global object? See, system. What is this? System.out. Out is a global object, isn't it? Out is a global object declared. See, exactly the same with public static final print stream out is equal to null, isn't it? So this is a global object in Java, correct? So you can have global objects also created like this. Now, why did I take this up? Because whenever, okay, now see this. Whenever there is a field visibility, okay, you know that what is that field visibility now, okay, declared as a field in the client class. The relationship will always be association, always thumb rule. The visibility will be, the relationship will be association, and that is denoted in UML by a line without any arrows at either ends, without any arrows at either ends. That means no arrows at all. Exactly the way we have done over here. No arrows at all. See, no arrows at all. Relationship is field visibility. Okay. Now coming back over here. Okay. If the visibility is anything other than field, any visibility other than field, it is known as the relationship will be actually dependency. Okay, so you see this here, dependency association. So if it is field visibility, it is association. If any visibility other than field, that means if it is parameter visibility or local visibility or a global visibility, the relationship is dependency. How is dependency shown like this? You know, there will be a dotted arrow wherein here this will be a client, and on the other hand this will be a supplier. That's how the relationship will be shown. Here in case a straight line like this, okay, not dotted, actually here it is automatically notes automatically does that, but otherwise client and supplier, and it is a straight line, not a dotted line at all. It is a straight line. You got that? And this is how this is actually a dotted line, client and the supplier here. This is how the dependency looks like. Okay, and now what is aggregation? So association ho gaya, dependency is done. Now see aggregation. Aggregation is a special kind of association. I repeat, aggregation is a special kind of association wherein the containment is there. That means aggregate. You can see this aggregate. One is made up of others. So I have these 5 things and I have got one single thing. You know, 5 things made up of this. One thing is made up of these 5 things. It is aggregation. Aggregate. Get it? Aggregate. That is called, that is a speciality over here in this association. And it looks like with a diamond arrow. I will come to that. You know, on UML diagram, I will show you. It's a special kind of an association, right? And then third, so wherever, you know, conceptually, there is a conceptual difference between association and aggregation. Conceptual difference. Okay, conceptual. Here it is like, you know, not a whole part relationship. Here it is whole part relationship. Okay, it is also known as whole part relationship. Now, finally, let me come to composition over here. You know, composition, I'll say this composition is again an aggregation. But in case of this is also aggregation, you may also call it is a special kind of association, one and the same thing. But there is and this is also whole part relationship. All of these statements are true about composition. Okay, whole part. But there is one big thing here. You destroy the whole, okay, all the parts will also be destroyed. That's the point here. You destroy the whole, all the parts will also be destroyed. That's what composition is. The best example is customer having customer addresses. A customer address always belongs to a customer. You cannot imagine any service to be invoked on customer address as a domain entity if it is not linked to some or the other customer. In other words, you destroy the customers, you will destroy the customer addresses also. If you are coming from RDBMS background like Oracle or Sybase or Informix or MySQL, there is a concept of foreign key relationship. Especially you've got a concept of composite relationship, wherein one of the keys in that composite relationship is a foreign key of the master table. You destroy the master table, you destroy a row in the master, all the child roles are also automatically deleted. That is called cascaded delete. That's what a composition is. In classes, that's what a composition is. You destroy the whole, the parts are also destroyed. So I have discussed with you all 4 relationships: association, dependency, aggregation, and composition. Okay, now the point that you remember, I will revisit composition later on, but let me go back very quickly to my diagram over here. Here I do not have in domain modeling. I may have compositions also, for sure I will have compositions also. We will come to that in a moment, but otherwise, you see, this is how the composition relationship actually looks like. You can see this here. Oh, sorry. Yeah, here it is. This is aggregation. I repeat, friends, this is aggregation. You will have a diamond here, and this side over here will be the whole. The other side will be the part. What that indicates, the whole over here. Okay, let me very quickly, drag and drop here. So if I have something over here like this, like this, okay. And if I have something else over here like this, so you will say if this is class A, and if suppose this is class B, suppose you will say the object of class B is made up of object of class A. But since this is pure simple aggregation over here, this is just a special kind of association, nothing different as compared to, it's just conceptual understanding that class B is made up of, instances of class B is made up of class A. But when I remove this relationship here, okay, and I put this one, you see there is a difference here. Here also I have a diamond, but this diamond is filled. Now this is composition. I repeat, this is composition. Now, what will I say? Class B, instance of class B is made up of class A. But if the instance of that class B is destroyed, all the related instances of class A will also be destroyed. That's what a composition is. You got this point clear? Right? These are the relationship and associations we have already talked about, right? Now, what is the difference, the major difference over here? I'll come to it. Differences as such, as you keep on doing domain modeling, you will realize wherever there is a whole part relationship, and we're going to come to it in this example also in a moment. So I'll destroy this now, and I come back over here. Now, the next thing that we need to talk about is, so we will be revisiting that composition part once again with respect to this case study, but then let me move on to something called cardinality. Very, very important, extremely critical. Because finally, yes, I've been saying don't think in terms of database. I've been saying this, but eventually you will have to design the database out of this domain model. I repeat, you will have to eventually, design a database based on this domain model. But first the domain model, then the database. Not the database first and then the classes. First the domain modeling first, and then the database. Based on this, you will have the database. Now you will go to the business. Right, whichever business. Now this business is so very clear to us that we all can relate to it. We have all studied in universities and stuff and all. We can relate to it. This is the case study. That is the reason I have taken. Otherwise, in real life, the businesses can be very complex, and you will have to go to the business and you will have to ask them questions. What kind of questions? You'll say, okay, one instance of course is related to how many instances of course offering? Kind of questions you will ask. You will say one instance of course offering is related to how many instances of course? These are the questions you will ask. One instance of students is related to how many instances of student schedule? This is what you will ask. One instance of professor is related to how many instances of course offering, and vice versa. How many instances of course offering will be related to, one instance of course offering is related to how many instances of professor. These are the kind of questions, and these kind of questions, an answer to these questions is known as establishing the cardinality. I repeat, that is known as establishing the cardinality. Okay, let me, I think I'm running out of battery, and I'll have to connect. Yes. Okay. Hope you are all with me, friends. All glued, with me. You are all there.
Yeah. Very interesting.
Great.
Very interesting.
Super.
Yes.
Super. Yeah. Super. Thanks. Okay. So coming back over here, we are now talking about cardinality. And this cardinality will help us to design our application further, as well as this will serve as an input to the database designer as well. I repeat once again, this is domain modeling, and this is what you are supposed to do for any new business application to start with. That's how you will start analysis in your design. So coming back over here, so what is that cardinality? How to identify the cardinality? Always your thumb rule, your question will look like this. Now I'm talking about cardinality. Okay, see cardinality here. Okay, this is what we are discussing. Thumb rule, given the two classes called class A and class B are like this. Suppose there are two classes. You want to identify, and there is a relationship between them, and you want to identify the cardinality. Okay, you want to identify the cardinality between the two. Thumb rule, your question must be like this, on from both the sides. So starting with class A side, from the side of class A, you will say one instance of class A is related to how many instances of class B. This must be your question. Don't worry about the answers. We will come to the answers later. Then from class B side, so from the side of class A, okay, this will be the question. From the side of class B, the question will be always, thumb rule, you always start with one. Always start with one. One instance, you will never get the cardinality wrong if you follow this. You will never ever get the cardinality wrong, right? So one, forget about that one to many, many to many, many to one, all that, forget about that. This is what you are supposed to do. One instance of class B is related to, class B is related to how many instances of class A. This will be the question. This will be the question. If from class A side you say one instance of class A is related to how many instances of class B, whatever is the answer, answer will always be on side of B, on side of class B. Okay, you will write the answer on the side of class B. Sorry, like this. हाँ, just give me a moment. हाँ, हो गया? सब अच्छे से हो गया? हाँ, कितने पैसे देने हैं आपको? ठीक है. वहीं रख दो ना. वहाँ रख दो. ठीक है? शुक्रिया. एक काम करो, ले जाओ. Okay, I'm sorry friends, let's come back here. So class A, one instance of class A is related to how many instances of class B? The answer will be on the side of class B. Similarly, here in this case, on side of class A. Okay, what all of this means, we are coming to it. But you understand, memorize this. Your question must always start with one instance of class A is related to how many instances of class B. If the entire question remains the same, only and only what changes is which class here and which class here. That changes. Otherwise, their question will always remain the same. What do you mean by an instance? Instance actually means nothing but an object. It's an object, correct? One instance of a given class is related to how many instances or object of another class. And the answer will be on the side of the other class. Correct? That's how it is. It's going to be very interesting. We're going to go back to our case study and we will see exactly how do we get the answer to this questions with respect to our case study. So going back over here. Now, if I want from the course side, what must be my question? One instance of course is related to how many instances of course offering. Just imagine, can't I have a course like, say, I'll say I have a course called Java. I have one course offering starting today, ending after 3 days. I have another course offering starting, maybe 10th of July and ending on say 15th of July. I have yet another course offering, and it's quite possible that this course offering starting from today and ending after 3 days is done by me, whereas the one starting on 10th of July and ending on 15th of July is maybe done by Ram. Quite possible. So course offerings, there can be several course offerings for a given course. Now the options that you have over here, I'm sorry, I missed that. What are the options of these kind of questions that you ask? There is nothing other than the following options that you have got. You will always either say 0 ... star. What does this mean? 0 or more. How will you read that star? More, 0 or more. Or else the option is you say 1 ... star, 1 or more. Or else you will say, okay, let me say, or 1 or more. No, I'm sorry. 0 ... star. I'll say, what does this mean? I'll say 0. How will I read it? 0 or more. 1 ... star. I'll say 1 or more. I'll say 0. Okay, well, you never have 0. I'll say 1. This is exactly 1. It cannot be 0. It cannot be more than 1. Okay, these are the only options available. Yeah, okay, that's fine. These are the only options that are available. 0 or more, 1 or more, 1. That's it. You will not have any other options here. These are the only options you have. So now let's come back over here. So one instance of course is related to how many instances of course offering. I will be very happy if you give me answers here in the chat window. One instance of, tell me, anyone can give answer. I'm here, I'm looking at my chat window. One instance of course, one object of course may be related to how many objects of course offering? 0 or more, 1 or more, or 1? 0 or more is the right answer. Right? Very good, Ajmal. Yeah, correct. 0 or more. Ajmal, why 1 or more is not the right answer? See, Ajmal said 1 ... more, huh, friends. But I really appreciate your answer, Ajmal. Very nice. But you know, when you say 1 or more, what does that mean? You will never be able to bring the object of course in existence till the time you do not have at least one course offering. But that is never the case. I may have a course created in my system. I may create offerings later on. Na? I have 0 course offerings. Quite possible I don't have any course offering. Am I right? So 0 or more is the right answer. Super. See, and that's the beauty here, of having Aram with us. So I have, well, cardinality option is not here. I will have to just go by text. What is this? Okay, no. So I'll go to general and I'll just pick up text over here. And here in the text, I'll say 0 ... asterisk. What does this mean? 0 or more. Got this here? Right? Okay. Then now from the other side, again, what must be my question? Can someone type his question over here? If you have understood, see what will be the question. If you want, I can give you the sticky note right in front of you. Tell me, how will your question look like? From course offering to course, what must be your question? One instance of course offering is related to how many instances of course? This must be your question. Correct? So now tell me what will be the right answer. I will be very happy, except for Ram, others can answer. Because Ram definitely knows the answer. So Ajmal, Tufel, you tell me, given a course offering, it will be related to how many? One instance of course offering is related to, see, one instance of, don't forget one instance. You are, Ajmal, you are one instance of class human being. One object of class human being. You're getting it? Okay. So one object of class course offering is related to how many objects of class course? Huh? Superb, yaar, Ajmal. Maza aa gaya, Ajmal. Excellent, marvelous. Exactly one. You cannot imagine a course offering launched and you say, well, which course? I don't know. 0. I'll decide later. I say, what? You'll decide later. You are announcing a course offering. You're saying from this date to that date, he'll be the trainer. Which course? And can it be more courses? No. For one particular course offering, there can be only Exactly one course. Now there is a debate over here. Suppose this is a real life case study. Exactly, this is real life. But then suppose we do have we do have a requirement from the customer from a university, and they have called us to actually develop an application, and we are in the phase of domain modeling. It's quite possible that we may enter into a debate. Why in this particular case? Why? It's quite possible Ram comes up and says, "Why, Shakir? I may have a course offering of say 15 days. There can be, for 5 days I have core Java, for 2 days I have domain modeling, for 3 days I have Scala. Why not? I can have 3 or 4 courses, correct? So tell me one thing, if that is the kind of debate that happens, to whom are we supposed to go back and finally get the confirmation? From whom? From whom? किसके पास जाके अजमल पूछेंगे हम लोग? To whom are we going to go and ask whether one course offering will be related to one course or to multiple courses? Ram, what do you think? To whom do you think we will be going back, Ram? Hello? Ram,
we should go to business only because they are the
super. Absolutely. We are going to go to the business. This is exactly the point. We're going to go to the business because these are known as, now take it from me, kahin pe likh lo, write it down somewhere. This is called, this cardinality is called structural constraint business rules in modeling. What it is known as? Structural constraint business rules, because there is a constraint on the structure of your domain here. In a banking application, one particular account holder or one particular customer of the bank can have how many accounts? The bank decides. They'll say, okay, you can have multiple accounts here, right? That's the bank who decides here. That is the business. And that establishes the structure. One customer related to many accounts. That is the structure of the domain. Hence, this is known as what? Structural constraint business rules. So this cardinality that we have talked about over here, my dear friends, this cardinality is actually known as in business modeling, structural constraint business rules. Right? This is what we are establishing. This is no joke. If at all you go wrong over here, you will have to refine your database design. That too, you will have to change your primary key and foreign keys. You will have huge problems. All the where clauses will change. You will have a huge havoc if you have got it wrong and you have gone halfway and then the business says, no, this is not how it is. It's a deadly situation. You're getting it? Structural constraint business rules are the first things that you must get it right. Well, in this particular case study, I will go by 1. Okay. So I will just duplicate this. I will drag and drop it over here and I'll say 1. Once again, my dear friends, how will I read this? I'll say one instance of course offering is related to one instance of course. And how will I read it the other way around? I'll say one instance. I'm not worried about this one over here. My question always is starting with 1, always, irrespective of what I have over here. I'll say one instance of course is related to how many instances of course offering. The answer will be on the other side, and I'll say 0 or more. So one course is related to 0 or more course offerings. That's how it is. Similarly, now very quickly, I'll be happy, Ram, if you give me the answer. My question is, one instance of professor is related to how many instances of course offering? My answer is supposed to be over here. What will be your answer?
It should be professor is down. Should be 1 or more.
Well, again, debatable, because I may have a professor inducted in the college, in the university, and I have not yet given him any course offering to teach as of yet. It's quite possible. So it will be 0 or more. The moment you say 1, there becomes a constraint. You cannot have a professor created in the system till the time you do not have at least 1 course offering for him, right? So it is 0 or more. Now, one instance of course offering is definitely related to what? Again, the same thing is exactly related to 1 professor, at least in this case study. 1 course offering is related to 1 professor, right? Now things are getting interesting. 1 instance of student is related to how many instances of student schedule. He may have enrolled for a degree wherein there may be 6 or 7 semesters or 8 semesters. So 1 instance of student, the answer will be over here. 1 instance of student is related to how many instances of student schedule? Now again, see, it depends again. 0 or more. 0 or more, when you say, that means A student can be inducted in the university. There will be a student persistent in the system, but he has not yet created the schedule. He will go on to the portal and then create the schedule, but student is already there. You got it? So 0 or more. One instance of student schedule is related to how many instances of student? Again, 1. Exactly 1. Am I right? One instance. If see, this is if there is a schedule in front of me that belongs to either you or it belongs to me or someone else, my schedule will be a different instance of student schedule. You getting my point? Different schedule. My schedule is a different. For example, I'm talking about the electricity board of your state. Electricity board of your state. One instance of consumer is related to how many instances of electricity bills? 0 or more. Am I right? Okay. One instance of one instance of electricity bill is related to how many instances of consumer? Exactly 1. It cannot be 0. Can you imagine you have received a bill and there is no name of the consumer there? And can you imagine you receive a bill and there are 2 consumers mentioned over there? Impossible. Exactly 1. It cannot be 0. It cannot be more than 1. That's how it is. You got it, Ram?
Yeah.
Super. Now the fun starts over here. One student schedule, please do not forget there is a requirement where I mentioned that in one particular schedule, there can be 4 course offerings. Am I right or not? And don't you think in one particular course offering might have been selected by multiple students in their schedule? Not my words. I'm talking plain business. This is how the business will talk to us. The business will say, see, when a student creates a schedule is created for him, and he will select 4 course offerings. And let's say, yeah, and any course offering can be selected by n number of students in their schedule. Am I right or not? In this case, now let me start. One student schedule is related to how many course offerings? Anyone can give the answer. I will be very happy. I'm just copying and pasting and keeping it over here, and I will give the answer here. Tell me, what must be the right answer here? One object of student schedule is related to how many objects of class course offering? 1 or more. Ram, you agree? 1 or more. In fact, I will say 1 or more is either I'll say this, or in UML modeling, this is also fine. I can say exactly 4. What does this mean? It cannot be 0. It cannot be 1. It cannot be 2. It cannot be 3. It must be 4. It cannot be 5. You getting it? Right? In other words, more. In other words, more. 1 or more. Okay. And you know what does this translate to? You may think this is a simple thing we are talking about. My friend, these are $1 million. This is the blueprint of entire software development. Entire software development. This is the blueprint. My user interface guy, when he looks at this, my user interface guy, he will create a user interface for registration. I mean, for creating the student. So student comes, he gives his username and password, he logs in, he gets a page. On the page, he will get the list of all the 100 course offerings, for example, the university has. Am I right or not? He'll have hundreds. How many can he select? Tell me. 4. Suppose he doesn't select anything and clicks on submit. He'll get an error. Sorry, select 4 at least. He selects 1, still he'll get an error. He selects 2 or 3, if he selects more than 4, he will get an error. You can select only 4. And a good user interface will do what? The moment he selects 4, it will disable everything else. You getting what I'm saying? See, the structural constraint business rules is the mother of your entire rest of the analysis and design of your application. Right? This serves as an input. You getting the point? Now, one instance of course offering. Here, I will tweak my question a bit. One instance of course offering may have been selected in how many schedules? In other words, one instance of course offering is related to how many schedules? Ram, you answer this question. Tell me, what will be the right answer here? One instance of course offering is related to how many? You know what, Ram? If I give you this to design the database, you will do it within 2 minutes.
Right.
I'm forcing you to think in terms of classes and domain classes. That is the reason. Otherwise, you will do it tap. Tell me one instance of course offering.
Is
How many student schedules? How, okay. One single instance of course offering might have been selected by how many students at the, how many students in their respective student schedules?
multiple. So multiple
Multiple.
students can select course.
Yeah, multiple, so more is fine. Will it be one or more or zero or more? It will be zero or more,
Zero or
correct?
more, right?
Because
Right.
you may have a particular course offering, no one registers, no
Right.
one selects that course offering in his or her schedule.
Right.
Possible. And you may have n number also, so zero or more. If at all your business says, now see this friends, this is so very interesting. If at all your business says that we will never allow more than 15 people to select a course offering, that is the batch size is maximum of 15. 15. So tell me, what will the answer be over here, 0 or 15? You got that? Now, how will you read this? One instance of course offering is related to how many instances of student schedule? 0 or 15. See, this becomes as an input to all your entire team for further analysis and design. In the service IMPL class, which class? Where you implement what logic? Business logic. There, the moment a new student schedule is created for a given course offering, you will loop through all the 4 course offerings the user has selected in the business service class, and you will check how many registrations has already happened. That means how many other students have selected that course offering. In their schedule, if the count is more than 15, you will give an error message, or whatever is the alternate flow. You will say, sorry, boss, 15 people already enrolled. You can see this, my dear friend, how $1 million worth of $1 million this entire diagram is. Right? This is called what modeling, friends? Tell me, what is this known as? What modeling? Hello? Domain. Domain modeling, right? This is called domain modeling. This completes this particular case study of ours. Now, Ram is our database expert. He's expert in everything actually. So data modeling especially is his field, right? But data modeling, and now Ram, you are getting into domain modeling. If this is what you do and you hand it over to suppose Achipal, okay, Ram, just imagine the situation. This is the application we are supposed to develop. This is the domain modeling that you have done, and you hand it over to Ajmal to do the database design.
Okay.
What will Ajmal do? He will create a table called course. Okay, very quickly, every one of you all. Ajmal, you tell me, okay, because he will be able to tell me very quickly. So I don't want Ram to tell me, but I want you to tell me. Give me the name of the primary key here. Give me the name of the column that will be the primary key here. Fast. Which ID? No, I've given course. Okay, let's have the prefix as the name of the. So there will be a table. Now I'm talking about database design. I am now talking about what? Database design. I will have this course. What will be the primary key? Course ID. Chalo, यहाँ पे course offering बताओ. What will be the primary key? Course offering ID. Course offering ID is the primary key. Give me the name of the foreign key. Will there be any foreign key here or not? No. What is a foreign key? Foreign key is the key in a particular table, which has a relationship to the primary key of some other table, by which it identifies. Like, this course offering is for so and so course. So tell me what, Ram, you can tell me. Come on, Ram, you can also participate, please. What will be the foreign key over here? What do you think will be the foreign key?
Course
foreign
ID
key.
of course.
Yes, very good. So course ID will be the foreign key. Yes. What else? There will be something else also.
Then
Which
we'll have professor.
Super. Professor ID as well.
ID.
Correct. So I'll say professor ID. Okay. I will just select this. I'll go to text. I'll set this, and then I will just simply change the color to, just to say that these are the, this is the foreign key. Okay. This is the foreign key. These red ones are the foreign keys in this table. You're getting my point? These are the foreign keys. Right. I'll just bring it closer. Okay. Again, here I will have professor ID as the primary key. Will there be any foreign key over here?
Not.
I don't think so. No foreign key.
No.
Now student. Will there be any foreign key in student?
Foreign key will not be there.
Right. So primary key will be student ID. Assuming, right, we are saying student ID is the primary key. Now in student schedule, what will be the foreign key to identify the student? I will have student ID is the student ID is a foreign key, isn't it, friends?
Yes.
Right? I will have student ID here. Student ID. Okay. Now the the most interesting part of this entire game starts now. Please check over here. Can I assume 4 to be more? It's more than 1, right? More. Here also, can I assume 15 to be more? More than 1 is more. Okay. Now, my dear friends, first of all, you have to tell me what will be the primary key in this? What will be the primary key of the table that will be mapped to this particular class? Tell me. Can I say student schedule ID will be the primary key? Make sense?
Right.
We already have identified the primary key for this course offering.
Right.
Okay. Now, Ram, you have to tell me. If you want, you can take a pause. If you want, you can ask questions. Tell me in student schedule, tell me how will I relate these two? In student schedule, will I have the foreign key of course offering? In course offering, will I have the foreign key of student schedule? How will I manage this?
In student schedule, I'll have a foreign key of course offering.
But one student schedule can have multiple course offerings. Where will I store multiple values? Again, as I said, if I would have given this to you for database design, you would have done it immediately. In course offering, also, I cannot have student schedule. One course offering has so many student schedules.
Course offering.
Okay. Let me elaborate. This is especially to Ram and rest of you. Please listen. Is Shivani there on the call?
No, she's
Okay, no problem. See this. I have a just imagine, Ram. Suppose your next door neighbor runs a small tuition classes in at home.
okay.
Tuition classes. Okay, and there are many students coming over there. So there is a concept of student over there. Okay, so she maintains a database of all the students. Okay, and student ID is the primary key. Correct. And what she does, and her business grows. So she has got other 2 3 friends of her. They also come, and 2 3 of them become teachers, and 2 3 of them actually teach the students. So students come in batches, right? So 3 4 students, when they come, one particular teachers those 3 4 students for say 45 minutes maths. Now those students switch over, they go to another teacher in the same flat, same apartment. They now sit with another teacher who teaches, that teacher teaches say science. Okay, and so on. So one teacher, so she will also maintain a teacher table, and she will have teacher ID. Okay, now she's your next door neighbor, and you are they know that you are an expert on database, so they come to you. So please create a small database in which we can maintain timetable, right? We maintain timetable. So how will you maintain the timetable? I actually gave you the answer. So how will you maintain which student teaches which teacher at what time? They want to put it on the note on the board somewhere.
Right.
Which student is taking tuitions from which all teachers, and which teacher teaches which all students at what time? If this is what you want to maintain, how will you maintain that information? So you will have a student table with student ID. You will have teacher table with teacher ID,
There. Then I'll have
right?
timetable table.
Yes.
And that we'll have student table. Then we'll have student ID, teacher ID, and the time.
Superb, right? And then you will have time over there. Don't you think this will be the composite primary key?
Right. Correct.
Am I right or not? This will be your composite primary key. So let me put a bracket here and close it, and then there can be other fields, whatever fields are, but this becomes your composite primary key. So you have in this example, I'll go back over here. I'll just scroll down. It will look somewhat like this in domain modeling. You will have teacher. Okay, you will have teacher. You will have student. Okay, you will have student. and there is a relationship between the teacher and the student here, and that relationship is, please note, the relationship is I'll pick this up. The relationship is a relationship which is many to many, you may call it in database. That means one teacher teaches many students, and one student takes tuitions from many teachers. Am I right? One teacher, so that one teacher teaches many students, and one student takes tuitions from many teachers. Yes or no?
Right.
Correct or not? In such a case, here also you will have 0 dot dot more, and here also you will have 0 dot dot more. Yes or no?
Correct.
In both the cases, correct? In both the cases, this is what it is. Let me make this as 20 over here so that it becomes crystal clear, right? This is how it is, right? You know very well what I'm talking about now. In all such situations where you have asterisk at both the ends, when I say asterisk, it is more than one is asterisk. Wherever you have something like this, you will have no choice but to create another table. Like in this case, it is a timetable table, and you will have an association class. Hope we have association class over here. Okay, we do not have an option of association class over here. That's just okay. But you know what? You will have a class and you will have a relationship like this. Like this. This is how the relationship will look like. And in this, you will have student ID. Okay. You will also have what else? You will have teacher ID. Okay, and here you will have time and all the other fields that you may need. This is called association class. Repeat this. What is this known as? Association class. This is exactly how you are going to model this over here. You see this here 15 also, of course, it is more than one, so it's more. Here it is 4, it is more than 4. In such a case, you will have to maintain the student schedule, or you can say student offerings, okay, or the scheduled offerings, you can say. I will have to pull in yet another class over here like this. Okay, let me bring this here. Let me bring, sorry. Okay, see, okay, let me reduce the size over here, and this, okay, and then I'll turn this to black as earlier. Okay, and here you see this, I will have a relationship running from here like this, right? Sorry. Okay, so I will pick this up from here. I will put it over here. I'll drag it and leave it here like this. Correct. Now there is a relationship here. You can see this, friend. I will call this as scheduled offering. Okay, that's how it is. What is this supposed to maintain? The relationship between the two classes. I'm sorry, thoda sa cluttered ho gaya ye. I will just move this here. And this bloody thing, I'm unable to catch hold of this. Mil gaya. Okay, like this, so that I can take this over here. Yes, this looks good now. Okay, I'll say 12. Here you are scheduled offering, and I'll touch hold of this as well. And I will stick it up over here. So sorry. Okay, this looks good, right? So this is what we have over here. This completes our entire case study here. Okay, but there are some other points with respect to our repository that I would like to talk about. And friends, please listen. We are going to always use this case study as a reference point. Huh? Yes, this is good. We are going to always use this case study as our reference point. Correct. This looks good. As a reference point. Okay, so now I'm going to, for this entire thing, I want to create classes in my database. I want to create classes in my database. Okay, so let me catch hold of this and let me bring this a bit down over here. Okay, this is not bad. Come on, friends. I want very quickly, I want you to tell me how many tables will be there in the database design. 1, 2, 3, 4, 5, and 6 tables will be there in the database. Very quickly, course, it will have a primary key of course ID, no foreign keys. Your course offering will have the course offering ID as a primary key, 2 foreign keys, course ID and professor ID. Your student will have one primary key called student ID. Your student schedule will have student schedule ID, and you will have one foreign key called for the student. Okay, and you will have a professor, no foreign keys, but in course offering you have the relationship to the professor. Now schedule offering is over here, and you can see this here. Here I will have two things. One is what? Student schedule ID, and here you will have course offering ID. Okay, I will take a pause here now. Just a minute. Okay, I'm not able to catch hold of this. Okay, I don't know why that. This is better. This is a simple tool, you know, and you have these kind of issues here otherwise. Okay, so here this is what? Course offering ID. Now, friends, I'm going to end this call here, but we are not ending our learning session here. I'm going to give you file. I'll export this as PNG. Okay, I'll say transparent background is good, or else no transparent background. Okay, and I will save it on my device. I'm going to share this with you. You can see this here. I have downloads. Okay, domain.png. Share this with you. Don't worry about your student and timetable side. For this part, for this entire part, okay, for this part, I want you to very quickly give me the model classes that will be there in your application. Just create any Java application. You're not supposed to run and execute that application at all. I want you to create a package called model. I repeat, I want you to create a package called model. In that model package, I want you to give me the model classes, the entity classes, you know, the ones that will map to the table in the database. As I said, we are not executing or anything, so don't worry about okay. And I want you to create the classes. I want you to create at least few properties so that we can relationship. I want you to create the repository classes for me. In your own existing application, just create another package called model 2. Okay, model 2. You can create a package called model 2, and in that you never name your package like model 1, model 2, but just simply model 2, because don't mix this with the other classes. Model 2. I want you to create all of these classes for me. I want you to design the repository for me. I want you to design the DAO for me. So you will have an interface called interface for each DAO, and you will have the implementation classes as well. That's what I want you to do. It's 12:05. Is 30 minutes sufficient? Because it's all about just creating classes and some properties over there. You know, is 30 minutes okay, or you need more time for this? I want model classes, repository classes, and DAOImpls. How much time will this take? 30 minutes. Ram, what do you think? 30 minutes is okay, or you need more time?
Yeah.
30 minutes is okay? Okay, fine. So I am sharing this on our WhatsApp group. Okay, this entire diagram, and your time starts now. I'm breaking this session now. I'm ending this session now, and I will start with the new session. I will share the link of the meeting. Thank you so much. Get started now.